Today we're going to look at 5.1 and 5.2. They go pretty well together, and since we're going to rely on the calculator a little bit more than your book would show you, we're going to condense them down some as well. A lot of this is going to seem like review, since you did these pretty heavily in Algebra 2 and a little bit towards the end of Algebra 1. So this first part we'll go pretty quick through. Reminder, system of equations is a set of two or more equations containing one or more variables. So when we say system of equations, it's just more than one equation put together. They share some variables. In general, you can solve a system that has no more variables than it has equations. So if you've got a system that has x and y, you need at least two equations to be able to solve for those two variables. Or if you had x, y, and z, three variables, you need at least three equations to solve. Less than that, you probably won't be able to do it. Then another fact, when you solve, what you're doing is you find a set of variables that fits each equation in the system. Kind of the same idea as when we solve for any equation. We're figuring out values that work. In this case, we're figuring out values that work in more than one equation. You do need to check them in all this. So if you see homework problems that say, is this ordered pair solution? Plug it in. If it works, it works. If not, it doesn't. When you do plug that in, you do need to check it in each equation. So if there's one of them that doesn't work in, you're still going to say it's not a solution. In the case of two linear equations, we can have three possibilities for how our solution is going to work out. Most often, we're going to see there's one solution. That would mean when you graph it, the lines intersect. Since they're lines, at most they're going to cross at one single point, and that's it. Another option, there could be no solution. When you graph it, that means they're parallel. The things that you're going to see that will tell you no solution when we solve, if at the end our variables cancel out and we get some kind of equation like 0 equals 4. Well, that's never ever going to be true no matter what x is, so that would be a no solution. And when you graph it, you'll see they're parallel. They never cross. They share no points. And the third possibility, infinitely many solutions. This would be when you graph it, you'd see that the lines coincide, meaning one line is directly top on the other. So essentially, they are the same line. When you're solving one of these, you'll know you've got this, as if, again, your variables go away, but this time you get a true statement, like 0 equals 0 or 4 equals 4. Either one of those would be a case where it's always true, so it's going to work out. So again, no solution. You're going to end up with something at the end like 0 equals 4. You know that's never true. It's no solution. Infinitely many, you'd get something like 0 equals 0. Well, that's always true, so infinitely many. Substitution is going to be the first method that we remind ourselves about. And really quickly, steps to get through that. First of all, you choose a variable in one of the equations to isolate. Make this easy on yourself. Choose the one that's already the most by itself if there is one. If there's not, then it really doesn't matter. Second step, you substitute that result into the other equation. So whatever that variable is equal to, you plug it into the other one. That's the substitution. Step 3, solve. So you'll have an answer for one of the variables. And then step 4, you're going to substitute back into step 1. And then you'll have your second order pair. Since these are linear, x and y, those are our two answers. That's where we're going to use substitution. So an example of this real fast. I got x minus y equals 5 and negative 3x plus 3y equals 2. So as soon as I see this, first thing I notice, that top equation, x and y are both pretty much by themselves, but x is really easy to get by itself because there's no coefficient, it's positive. So I'm going to rewrite that, x minus y equals 5. And all I need to do to get x by itself would be add y to both sides. Remember, those are not like terms, so I cannot combine them. So I just write that as y plus 5. And that's my step 1. I got a variable by itself. Step 2 says I take that and I plug it into the other one. So here, instead of x, I'm going to write what I got. So negative 3 times my y plus 5 plus 3y equals 2. And then solve for y, because now I'm down to one variable, so that can be done. Distribute, so negative 3y minus 15 plus 3y equals 2. Again, I can combine my like terms here and here. So I get negative 3y plus 3y, which cancels out. So I get negative 15 equals 2. Now right there, that tells me what the answer is, because negative 15 is never equal to 2. So that tells me this is a no solution. So I can stop exactly at that point. Yeah. Now, if I wasn't getting that, then I would have got an answer for y, then I would have plugged that in and found x. For this case, we are done with that particular one. No solution. The other type was elimination. Somebody else did in Algebra 2. With this one, you choose a variable to eliminate, and just like substitution, if there's one that's easier to do that one, but really it doesn't matter. Either one will work. Step 2, you're going to multiply one or both of the equations by a constant so that when added, the chosen variable is eliminated. So you choose who you want to knock out, who you want to eliminate, x or y or whatever variables you got. Step 2, you actually do that. And sometimes you might have to multiply one of them by something. Sometimes it may be both of them. Sometimes maybe neither one. It just really depends on the system you're given. Step 3, you'll solve the remaining variable, whichever one it is. And then step 4, you'll substitute to find the other variable. So you plug back in, you get your answer. So an example of this, 3x minus 2y equals 0, and 5x plus 10y equals 4. When I look at it, what I see to begin with, 3 and 5, I could make those happen, but they're both positive, and I'd have to multiply both of them. So it could work, but I think what's easier is, if I look at this, I've got a positive 10y, I've got a negative 2y. And think to myself, well, could I turn one of those into the other one easily? And yeah. If I take this top equation, the whole thing times 5, I'm going to get 15x minus 10y equals 0. And then I'm going to write down the other one because I didn't change it at all. 5x plus 10y equals 4. And I like what I see because right now, if I add these, sorry, I should have done x there. 15x plus 5x gives me 20x. Negative 10 and 10, gone. So equals 4. I just eliminated the y. I changed the other one into negative 10, so it cancels out with positive 10. Then to get x, all I need to do is divide, and I'll get x is 1/5. Then I take that, and I can plug it back into either one up top. Usually just pick out which one looks easiest. This one doesn't look too bad. I do 5 times a 5th plus 10y. Should set that equal to 4. 5 times a 5th gives me 1 plus 10y equals 4. Subtract, so 10y equals 3. So y equals 10/3. And then that would be my answer. If I wanted to, just make sure I'm right, it's really easy to always check these. You just kind of plug back in. Like up here, if I do 3 times a 5th minus 2 times 10/3, well, if that's my answer, those should become 0 when I combine them. So right here, I've got 3/5 minus 20/3. So when I do that, I don't get 0. So that tells me I did something wrong, which is fine. So I'm going to look back at my work, and then right here, when I look, I noticed, oh, there was a mistake. Instead of 10/3, that should have been y equals 3/10. Then if I plug that in, I would get 3/5 minus 2 times that, so 6/10, which is the same as 3/5, so I do get 0. So it is recommended that you do kind of plug that back in to check out, because a lot of times you're going to have a lot of work here, and it's really easy to make some little mistake, as many steps as you're going to have. So 1/5, 3/10 is the answer there. Again, make sure you do like I did there and actually plug it back in, make sure you're right before we move on. The third option, which most of the time this isn't worth doing if it's linear, but it's a possibility. You can also graph to solve. To do that, what you need to do first is get each equation in slope-intercept form, which again would mean get y by itself. So get y by itself on both of them, graph it, and since we have our handy graphing calculators, to get a really accurate answer, we probably don't want to sketch it because it's probably going to be off. We'll use the intersect option on the calculator. So that's where you graph both of them. You go to your calculate menu, choose your intersect option. It'll have you pick the lines, and then you'll be able to get exactly what the answer is. So you can do that. It's usually not going to be the fastest way, but it's a possibility if you blank out on how to do substitution or elimination. And then the last thing that we'll talk about today would be matrices. Again, something else you did a lot of in Algebra 2, so we're going through it kind of quick. We will use this to solve systems of equations that involve more than two variables. It can be done by hand, but since we got the calculators, we can get through this a lot faster. What we'll do is we'll rewrite a system of equations as an augmented matrix. And let's say I give you this system here, 3x plus 7y minus negative 8z equals 12. And then I also give you 4x minus 9y equals 2. To write this in matrix form, I just look at the coefficients. I got my bar there. On this one, I'd have 3, 7, negative 8. And wherever you see your equal sign, that's where you put your line. That's the augmentation part. And then the 12 goes there. On the next one, I still have 4. I got negative 9. But since I don't have a z there, I'm going to go ahead and put a 0 in as a placeholder. 2, close the matrix. And that's how you write that in augmented matrix form. It's pretty easy. When we're working these out, I generally won't write that necessarily, but that's how that works. And again, if there's a variable that's missing in one of them that was in one of the other ones, make sure you put in a 0 as a placeholder. If not, it'll really throw things off. So what we're going to do again can be used in conjunction with the graphing calculator to easily solve complex systems. By hand, probably fastest to do elimination or substitution if it's a linear one. If it's more than two variables though, this is how I'm going to want you to do it, is on the calculator. And I'm going to walk you through that on this next example. So we're going to solve 2x plus y minus 3z equals 0, negative 2x plus 2y plus z equals negative 7, and 3x minus 4y minus 3z equals 7. So my first step is going to be to rewrite this as a matrix. So I'm just going to do that real quick. I've got 2, 1, negative 3, 0. I've got negative 2, 2, 1, negative 7. I've got 3, negative 4, negative 3, and 7. Now from there, I'm ready to go to the calculator, which we'll see how well this works, that thing I was working on last time. And I should be able to just type this in like you had. This is an 83 model, but it's a lot like your all's 84. So turn it on. And we're going to go to our matrix menu first. So you go second, and then it's above the inverse key, and go to matrix. From there, you're going to want to edit. So go right to edit. And it's all right as long as you edit the first one, probably. Hit enter. If you've got anything in there already, you don't have to necessarily delete it. It'll happen automatically. Since this is a 3x4 matrix, I've got 3 rows, 4 columns. That's what that should say. So make sure you've got 3, 4, and then it should bounce you down here to start inputting things. So you just start typing. We've got 2, 1, negative 3, 0. Then second row, I've got negative 2, 2, 1, negative 7. And then I've got last row 3, negative 4, negative 3, and 7. So hit enter just to make sure that got put in there. And kind of verify that everything got put in right, and then just looking really quick at this. Once you put in your matrix, what you're going to do next is quit out. So just do second mode, so you're back to your home screen. Now we're going to go back into the matrix menu. So hit second inverse to get back to matrix. And this time, instead of editing, we want to go over to math. So go to the math, and then we want to go down to reduced row echelon form, which is option B on this one, where it says RREF. Hit enter on it, and it's going to take you back to your home screen. Now you need to tell it which matrix to do this with. So we'll hit second matrix again. We want to choose matrix A, since that's the one we edited. Hit enter. Close that parentheses, probably a good idea. Hit enter. And it's going to give you the matrix that is our answer. Now, if you actually have a solution, what you're going to see going across is 1, 1, 1 across that diagonal. That tells you when x is 1, that's what it is. So I'm going to write that down. So when x is 1, or when we have 1 for x, we've got 4.3-ish. So that's one answer. X equals, just going to go 4.3. Y is going to equal, back at it, about negative 0.54. And Z is looking like 2.69. Now, to actually get a solution, what you're checking is make sure that going across that diagonal, it's 1, 1, 1, and then everything else should be zeros. If you get something at the bottom like 0, 0, 0, like let's say that was my last row when it gave me reduced row echelon form. Let's say I had something that was like this: 0, 0, 0, 12. What that would be saying is 0 is equal to 12, and just like before, that's what tells you no solution. So you'll have to look for that. And that's it. So be able to do that. Your assignment is up there now, page 516, 7 through 39, every other odd. And then the last 5 are the ones you'll do on the calculator, just like our last example: 41, 43, 45, 49, and 51. And that does it.